Okay, in this video, we are going to do a simple problem. Silver metal has a face-centered cubic unit cell with a length of 407 picometers. What is the radius of a silver atom? Okay, and just so you know where all this comes from, we can do something called X-ray crystallography, and you you bounce X-rays off of a crystal lattice of like a silver, for instance, in this case, and you'll get what they call an interference pattern. And from that, you can figure out things like the length of a unit cell. It's certainly not an easy process. And also, coincidentally, they can use that to figure out the structure and shape and other things about proteins. For instance, on something like a coronavirus, you can figure out what the proteins are on the surface, what their structure is, and then you can, pharmaceutical chemists can figure out how, or biochemists can figure out how to design drugs against those proteins to keep it from, say, binding to your cells or something based on what's called X-ray crystallography. Okay, you'll probably hear more about that in other classes, but not in this class. So hopefully you got that all copied down. Okay, we're really only given one value, and that's the side of this unit cell is 407 picometers. It doesn't matter which side we pick either, okay, because this is a cube, but from there to there is 407 picometers, okay? And now, let's talk about how we're going to go about solving this. Okay, you'll notice that all of these cubes, they touch each other. Or, I'm sorry, all the spheres touch each other. So if we can figure out, kind of along this diagonal, how many radiuses we have, I think we might be able to solve the problem. Okay, so let's just talk about along that radius there, I'm sorry, along that line there, that diagonal, how many radiuses do we have? Well, from the corner down here to the edge of the red, from there to there, that's one radius. Along the green, that's two radiuses, and again, from the edge of the green to the corner, that's one radius. Okay, so our diagonal is 4 radiuses. Well, what else do we know? We know that this, we'll just call that L. This whole side, we'll call L. And this whole side, we'll call L. And now all we need to do is remember a little bit of geometry. Geometry, what the heck is that? I know you guys took it way back in high school, but we're going to bring it up again. Because if we use the Pythagorean theorem, this is a right angle. So we know that L squared plus L squared is equal to 4r, which is the total number of radiuses across that diagonal, squared. It's just the Pythagorean theorem. A squared plus b squared equals c squared. So now all we have to do is simplify. Let's see, we get 2l squared is equal to 4r squared. And let's just take the square root, and we get 2l. Square root of 2l is equal to 4r. Just taking the square root of both sides. And then we get L times the square root of 2 is equal to 4R. And then we'll rearrange a little bit. And R gives us L squared, or L times the square root of 2 over 4. Okay. So if you didn't catch all that, go ahead, back the video up, watch it again. Just algebra. So we know the radius in terms of the length of the side. Go back up. We know the length of one side is 407 picometers. Now really it's just a matter of dropping in the numbers and we can solve. Okay. So R is equal to 407 picometers times the square root of 2 all over 4. And that gives us 144 picometers. All right. In the next video, we are going to talk about the density of silver. Basically the same idea, but we're going to do density.